Recording in progress, thanks to the nice robot lady in Zoom. So today is lecture 7. This is part 2 of materials. Good morning, everybody, if you're just joining us. So, as I mentioned, this is part 2 of materials. And today we're going to focus on transparency, transmission, and refraction. All right, so let me get a screen grab here for attendance. There we go. Just make sure I don't miss anybody. Okay, so office hours tomorrow are going to be a little bit different. I usually have them until 4 p.m., but tomorrow I have an online Q&A session at 4 o'clock. So my office hours will be 10 to 3 tomorrow. But you can still head over to Discord and get help. Ari will be there. We have our ACD, Anthony Bagsby. He's on vacation, so I'm filling in for some of his classes in shading and lighting. So it's going to be a little busy this week. But I will have office hours 10 to 3 on Tuesday, and then the usual 10 to 4 on Thursday. Frank and or Ari will be doing the optional Zoom Open Lab. Again, different link. Don't forget that's at the bottom of the schedule that we have. That is for campus and online students. And tomorrow, Project 6 is due, the material discussion, and don't forget the research discussion. So the research discussion, if anybody missed the Friday presentation, go watch the first part of lecture 6 on Friday, where I go over the research discussion, what the requirements are, kind of some tips for, how to approach it. All right, so as I mentioned, we're going to be doing transmission, refractions, transparency. We're also going to be utilizing the index of refraction. Now, when we were dealing with metal, we went to the refractiveindex.info, and you'd look up metal and it would have a refraction index there. The refraction index we're going to be looking at for today is going to be just glass, liquids, and maybe transparent plastics, because we're interested today in see-through objects. Well, not necessarily see-through, but transparent objects. Now, transparent objects like air is considered neutral. So air has an index of refraction of 1.0, whereas water is something like 1.3, glass is 1.5. Let me see, alcohol is usually around 1.4, plastics are around 1.4, somewhere in there. A diamond, which is very dense, that is 2.42. So the higher the index of refraction, the denser the material, the more it's going to reflect, and the more it's going to refract light as it passes through. So we're going to try and tie all that together and how it works with the AI standard surface. Because just like we had that little checklist for metal, we're going to have one for glass as well. And glass has a couple of unique issues going on with Arnold that we have to kind of navigate around. All right, so let's talk a little bit about, Frank did his presentation for you guys on Friday on reference. So let's just kind of recap the reference part of what we went over Friday. So reference, basically for reflective materials, specular, there's 3 things that your reference should tell you. 3 primary things, let's say. So what are they? Anybody remember? Yeah. How reflective? Allegra says color. Good. Color is one of them. Yes. How rough or smooth? Very good. Now, when we deal with transparent materials, we're also going to be dealing with all of these, but in addition, how transparent is it? What kind of transparency? How transparent, and let's call it refractive also. For example, we look outside in our classroom. If everybody turns around, you look outside, we've got 3 windows. We've got one in the wall, we've got a big giant window pane next to the door, and we've got a little portal. When you look through that, can you see any refraction? Can you see anything that looks like it's being bent as it passes through? Now, generally not with a window pane. When you're looking through a window pane, we're not really comparing like half of outside and half of inside. We're just looking through a portal outside. Now, when you are dealing with window panes, most of the time we don't see refraction unless, of course, it's a big bowed window or it's got some kind of special shape or it's made out of a special material. But most of the time, you know, architects, building construction supplies, they usually try to make glass windows as, well, for one of a better word, transparent, you know, where you don't notice that they're there and you don't pay attention to the refraction. So how transparent, how refractive, that's going to be kind of what we're looking for in our reference for glass, whether it has color in it or not, and also, believe it or not, our liquids. So for example, I have a bottle here, plastic on the top, it's got liquid inside. So when we model this object like it exists in the real world, we are actually modeling 2 separate surfaces. You have to model the bottle, the container, and then you have to model the body of water inside. That's because the water as a shape will have its own material and its own index of refraction. The plastic outside will have its own material. It has its own shape, and it's going to have its own index of refraction because we can see through it a little easier than we can with the bottle and the water. So when it's just the bottle, it's a little easier to see through. Kind of hard to see here with my little tiny camera, but you can kind of see my glasses and mask through the transparent part of the bottle up here. All right, does that kind of make sense? Questions from anybody? So Allegra, Damien, Dia, Griffin, Tristan, everybody's good. How about you, Diamond, Adriana, Jasmine, any questions? Everybody good? Okay, thank you. All right, let's clear this. And let's go on and talk about transmission. So transmission occurs when you have a light ray that hits a surface at a perfectly perpendicular angle, meaning it is exactly 90 degrees from the surface, straight down, straight on. Now, in addition to the light ray being straight on, the surface or the material that the light ray passes through also needs to be clean, clear, pure. For the most part, the air in our atmosphere, in our environments, is pretty clean. You know, you go outside, yeah, we might have maybe they're doing a controlled fire burn here in Florida, so it's a little smoky. Or you go out in the middle of the day and it's really humid and you can see the moisture in the air kind of acting up as light passes through it. But in general, our air is fairly clear. Go inside and, you know, we all have air conditioning, so the air gets filtered a lot. So it's a lot clearer, but light rays usually pass through unobstructed in air. Now, glass also, if a light ray were to pass through there and transmit, it needs to be fairly pure. And like I said, that ray needs to hit the surface at a perfectly perpendicular angle. That's called transmission. The light ray is not obstructed or altered in any way in its path. Now, when we have a light ray that hits a surface at what we call an incident angle, meaning anything other than perpendicular, that light ray will tend to bend slightly depending on the thickness of the surface it's passing through, the purity and quality of the glass or plastic or liquid. So when light bends as it passes through a medium, it could even be air. Even, you know, on those humid days in Florida outside in the parking lot, you'll look in the distance and you can kind of see wavy patterns in there. Okay, the light is being refracted or bent as it goes through all those little water molecules. So that is when we have refraction. So transparency doesn't necessarily mean, when we're talking about glass, plastics, water, liquids, it doesn't mean it doesn't exist, because a lot of times we think of transparency as something that's removed, it's invisible. Well, it's visible, sort of, like our air is not really visible. We can see the effects in the air. So it's not that it doesn't exist, it's just that the light rays are not being altered. So consequently, it looks invisible, it looks neutral to us. Now, when we get on and we start talking about surfaces, for example, we have, you know, kind of a goblet wine glass here. I'm sure you guys have modeled something like this in model creation or in 3DF. Right? Usually you start with a little CV curve, go all the way around, snap it to the midpoint, do a revolve, output polys, and you're pretty much done. But we build this surface like it exists in the real world with an inner and an outer wall, because we need to have the area between the inner and the outer wall be our material. We needed to describe when a light ray or when any ray hits it, we need the material to tell that ray what to do. So for example, when we have our plain old AI standard surface diffuse material on there, right? Light ray is going to hit it. The material, you know, the light ray or whatever ray, could be a camera ray, could be a reflection ray, any kind of ray hits it, it's going to, you know, query the surface, go, hey, what are you made of? And it's going to go, hey, I'm a diffuse material. So, you know, the ray is going to behave according to what that material is. Hey, I'm going to scatter in all directions. Or I'm smooth, I'm hard, I'm plastic. Or I'm metal. Okay, nice, smooth, hard surface like that. Light ray hits it, or any kind of ray hits it. You know, the ray says, hey, what are you made of? Hey, I'm smooth, I'm glass. Oh, okay, glass or metal. Oh, I'm going to bounce back at an incident angle. I'm going to bounce back more organized, don't have to scatter. And honestly, it's not just the ray doing that work, it's a combination of the renderer, the ray, and also the surface. Remember, those three things we need to be visible when we're dealing with rendering or just making anything visible. You need a camera, something to record it. You need a surface with a material on it, and you need light. Light is our primary key because everything we see is a result of reflectivity. Now, when we have glass, then the surface says, hey, I'm glass, I'm transparent. Here's my index of refraction. So then our light ray coming in, whoop, hits the glass surface, says, hey, what are you made of? Surface says, hey, I'm glass. My index of refraction is 1.5. You can pass through, but you need to bend according to my index of refraction. So the light ray bends according to the index of refraction and then exits. Comes down, hits the inner wall because, okay, well, let me backtrack a little. So it goes through the material, exits. What's inside the glass? What exists inside that glass right now? Yeah, thank you, Allegra. Air. Josh says air too. Air. Air is fairly neutral. So index of refraction, I'm going to abbreviate it IOR, 1.0. So it's going to pass through fairly unobstructed. It's going to transmit through as though there's nothing there. And in CG, there is nothing there. We don't need to model air, unless, of course, we're going to do some kind of fluid effects where we've got clouds or we've got wind or something. All right, now, when our ray goes through that air inside the glass, hits the inner wall, and it says, hey, what are you made of? Well, hey, I'm glass. You have to bend according to my index of refraction. So the ray bends according to the index of refraction again, and then exits once it goes through. And then whatever it hits outside there, if it doesn't hit anything, it's usually considered to be air outside here also. So unless it hits something else, it's fairly neutral out there. Now, this is pretty important for us because we need to keep track of all the surfaces that either a camera ray or a light ray comes into contact with, because we need to be able to see through things. So we've got one point there, got another point here. We have another point here and another point here. Adriana said, would be different if there was liquid inside. Yes. We're going to get to that in our next phase. Right now, I'm just trying to go through what is in the glass that we see now. But you're absolutely right. It's a different process because we've got an extra surface inside. All right, so we've got 1, 2, 3, 4. That means we need to tell our renderer, hey, expect to be able to go through 4 surfaces. Now, fortunately, most renderers use 4 or some even use 6 as a default. So if you make a simple glass, you know, I'm thinking drinking glass when I say glass, a simple drinking glass, and render it, you should be able to see through it. But here's the thing. If you stick a glass in front of another glass and they overlap in the view of the camera. Now, you can have 2 glasses side by side, and your camera is going to see 2 individual glasses that have 4 surfaces. But as soon as those glasses start to overlap, then the camera's got to go through one set of glass, which is 4 surfaces, and immediately go through another set of glasses where they overlap. So I'll draw a very poor kind of counterpart to our wine glass here. All right, so of course this would have an inner and an outer wall. So now this is wherever we have the overlap, which would be right in here. That's where we would have to calculate how many surfaces for that camera to see through. Well, remember, each glass is going to have 4. So it's 8, yeah. 8 wherever it's overlapping. So let's see. Here, you would have 4. Here, you would have 4. But where the 2 overlap in the camera's view, you would have 8. That makes sense. All right, good. Now, to get back to your question, Allegra, about would it be different if there's liquid inside? Let me erase all the non-essential stuff here. And I'll just keep all that. And let's get rid of that. Well, let's get rid of this altogether. And for this, let's go. Let's go like deep red here. Now that doesn't show up very well. Let's go lighter. Yellow might be too light. Or yellow. There we go. That'll work. So pretend we've got liquid inside the glass here. Now, did they ever show you guys either in 3DF or model creation, did they ever show you how to model liquid inside a vessel, inside an object? Okay. Well, generally, you go through the trouble of making the wine glass, right? But you want the liquid inside to conform to the shape. So what you can do is just select the faces inside, you duplicate them, scale them in ever so slightly, and then you cap it off on the top. That's the easiest way because you've taken faces that are already shaped into the container, which doing that kind of method allows you to make unique container shapes and have liquid conform to those containers inside. That's generally what you do. Now, when water is, there's something that liquids have when they are in a container called the surface tension. And surface tension means that there is a little bit of, it's not a skin on top of the surface, but there's, in the container itself, there's a little bit of pull on the sides of the liquid so that they don't line up perfectly like 90 degrees on a container edge. There's just a little bit of pull inside. I guess it's based on water pressure or whatever it is in there. And that little bit of surface tension allows, you probably have seen those little insects that can run across the top of the surface. Well, they're distributing their weight so much and they're so light that they don't break that surface tension, and they move quick enough and they just kind of hop over the water. Looks like they're actually walking on the water. But in reality, when you model the edges of a container with liquid in it, you don't model it so it's a perfectly 90-degree angle. You model it so it kind of pulls away from the top just a little bit. Basically, put holding edges on it so it kind of rounds off a little. Makes it look a lot more natural. So, what that means for us is we've got our liquid modeled inside, and now we need to decide what is the liquid has its own material. All right, so let's say this is air 1.0. This is glass. We'll say that's 1.5. That's the index of refraction, IOR. And now we've got, well, you know what? We'll call it water inside there. So we've got water here. It doesn't matter what it is. It's going to have its own material and its own index of refraction. Water is 1.3. Wine, something like 1.37. It's a little bit different than water, but. So now our ray hits the outer surface, queries the material. What are you made of? I'm glass, index of refraction 1.5. It bends. It goes through that surface, and instead of hitting the air, it immediately hits the next surface, which is water. So our index of refraction is changed for water. So now we've got number 3 here. We've got number 4 here. This one's number 5. And this one down here in the bottom is number 6. So now our ray hits the outer wall, bends according to glass, exits, hits the inner wall, or I should say outer wall of the water. Now this is solid. There is no inner wall, outer wall. It is a solid mass. Just like if you took this glass, filled it up with water, put it in a freezer, and it froze, and you were able to get that out, it would be a solid, and it would conform to the shape of the glass. So this would bend according to the index of refraction of water. It would immediately exit on the other side and hit the glass again, would bend again, and then exit the outer wall. So for a glass with liquid in it, we have to worry about 6 points of entry. So our camera ray, our light ray, we have to be able to see through 6 surfaces. So a standard like 4-surface refraction or transmission ray, standard 4 would stop in the outer wall. So we would be transparent, then it would hit a wall and just display dark. That makes sense. Any questions so far from anybody in Zoomosphere? With liquid? Yes. Unless there was some other kind of special circumstance with that glass. Like maybe it's a bottle and it's got something else going on, so there might be more surfaces, which will be the case when I show you some of the bottles that you're going to deal with inside in the interior. So those bottles were specifically chosen because of their properties. All right, Griffin's good. Allegra's good. Let's see, how about Damien, Daya, Eel? Damien's good. Josh is good. Thank you. Tristan. Everybody good? All right. So now, if we had a glass with liquid in it in front of another glass with liquid, how many surfaces would our ray have to go through? 12, yeah. Because you can basically look at each glass container as a separate entity and just add the two containers together, or you can just count all the surfaces. All right, so don't worry, Allegra, it is not, it sounds scary, but we're just trying to understand what we see and how we deal with it in CG. It's really not that difficult, so don't be too scared. So the software does all the work. All you have to do is worry about counting how many surfaces and stuff. And we'll get to all the kind of fine points. And actually, if you go through the checklist that I have, just like with metal, it should be pretty simple for you guys. All right, so let's clear this. Let's move on. So today, we talked about conservation of energy with reflectivity, where everything that we worked on pretty much through Project 5, except for the portrait, was all diffuse. So that's where all the energy was. We started adding reflective energy, which will drain the diffuse. So as the specular or reflectivity goes up, the diffuse goes down. Now, when we deal with glass, there's basically going to be no diffuse at all, because glass is mostly transparent or transmissive and a little bit reflective. So we steal energy again, this time all the way from the diffuse, and we steal energy from the reflectivity, because glass is more transparent than it is reflective, unless, of course, you have a special like metal coated glass where it's very reflective and transparent. So specular and transmission work together. The good news is, once you have your specular set, you usually leave the weight at 1 and you leave the color white. The color's always white in specular, except for what? We dealt with this last time. Remember when we made metal? Yeah, well, when it's red metal. Because red metal reflects back all the reflections in the environment with a reddish tint or orange or yellowish tint. So all the other reflections should be white, meaning they're kind of neutral, and the color is going to be based on the environment, that dome light with the image in it for us. So using one or the other can result in interesting effects, but it's not intended by design to be physically accurate. That's why we need to have that specular weight left at 1 and the color at white. Now, here is where we get the index of refraction. For glass. You would think it would be down here under the transmissive part. But remember, reflectivity is also controlled by the index of refraction. Now, when making glass, the base weight will interfere with your look. It will make it look muddy. It'll make it look cloudy. That's why we turn off the base weight. So diffuse gets shut down to make pure glass. So base off, specular at the default, IOR, index of refraction. Believe it or not, that 1.5 is the default index of refraction. Then we come down and we add in transmission. Now, by default, transmission is turned off. But to make glass, you turn it up to 1, you leave the color white, and you've got clear glass. When the color in transmission is white, let me find it right here. Oh, I always have something plugged in there. Yeah, and I'll show you why I have stuff plugged in a second. When you turn that transmission up to 1, the transmission color should be white. That will give you pure clear glass. Color for glass comes in to the transmission color, not through the base because the base is turned off, not through the specular because it's not metal, through the transmission. That's where you get your red glass, your tinted, your dark, you know, whatever you want to put inside that glass. All right, specular weight controls the amount of reflectivity, roughness, index of refraction. So specular weight set at 1. Specular color, keep it white. Specular roughness, this will adjust how much the reflection rays get dispersed. Now, you guys, I'm hoping, are all familiar with frosted glass. Or, you know, you pour a cold drink into a glass and the air is warm, that glass immediately kind of fogs up. Basically, the water inside is colder than the air outside. It makes the air out, the moisture on the outside condense around the outside of the glass, making it look foggy. But true frosted looking glass is a combination of having the reflection rays dispersed and the refraction rays dispersed. So we kind of talked about this: specular weight, keep it at 1, specular color, keep it white, roughness. This is going to be used with transmission roughness. The two together make up how glass should look. Most of the time, glass is very low roughness. Now, I've just got roughness on here just so you can see what it looks like. The default roughness is usually way too high, so we have to turn it down. Now, transmission weight. This part gets a little wonky, but transmission weight, if you turn it all the way up, you'll have clear glass. No problem whatsoever. But the problem is, in Arnold, our shadows disappear. So there are a couple of things that we need to plug into the transmission weight to get them to reappear. They're called a gamma correction node and a sampler info node. Now, it sounds scary. Don't worry about it, because you're going to get good at doing it. Because in order to have glass that has shadows in it, you need to be able to do these two things. Now, the one exception is if we're making glass panes. We don't see shadows from window glass, right? We just see light coming in. We don't see a shadow from it. So making glass windows, we don't need to worry about shadows. We don't need this gamma correct or the sampler info. Now, as I mentioned, transmission color, this is where we get color from glass. So transmission has something not just called transmission roughness, but it's called extra roughness. It's like, ooh, it sounds like you're going to pay more at the gas pump because it's like extra super. Even though your car still runs the same, you're just paying another $1 a gallon for it. So adjust how much the transmission rays get dispersed or diffused. So this is an example of what transmission roughness looks like by itself. Their specular roughness, they kind of, oops, went the wrong direction. They kind of almost look the same, but when you combine the two of them together, you can see that actually does feel like a frosted glass. That feels like something that was sitting in the freezer, you take it out, and now you fill it with a beverage, and not only is the glass itself being, diffused, the transparency of it, but also the reflectivity of it. Like I said, any roughness in glass is going to be minimal unless you've got reference that has a frosted glass in it. And for the most part in this exercise, we're not really interested in a special effect like that. We just want to make sure that you guys can understand how to make good, clear glass, how to make glass with color, how to make liquids that you can see through. Now, granted, there's a lot of wine reference out there that is really dark wine and you can't see through it. For our exercise, that's too dark. We want to be able to know that you can make something dark enough, but still see through it a little bit. We also want to have that shadow be visible so we can see the color as the light passes through it. Okay, so a couple of other little switches we need to turn on for glass. Okay, these are all under the AI standard surface. So under advanced, we've got a little switch called caustics. That will add a little extra sparkle to the glass. So for example, caustics, see if I can get this to happen here. Going to take off my headset. And let's see if I can make this visible for everybody. Let's see. I guess I need to stop sharing my screen so you can see the camera. And let's make this speaker, which is me. There we go. Okay, so let's see if I can get this to show up. I don't know if you guys can see that, but there should be a little bit of sparkle right here in that bottle as the light passes through it. My hand is exactly in the way. Boy, I would be a terrible weather person. Like I can't get, oh, this is backwards. I got it. So can you guys see that? Kind of little sparklies that are happening inside the reflection. Yes? Okay. That is caustics. All right, let's go back to, well, first let's share again. There we go. Wait, did that share? Share? Okay. Can you guys see in Zoom my screen? Because usually it has a big green bar around it. Okay. Just want to make sure I didn't lose it. Okay. So caustics. Then we're also going to increase what's called the indirect specular highlights. That also adds a little bit more brightness to the glass itself. Now, when you're making glass window panes. There is a section inside the material called geometry. Geometry allows you to turn on what's called thin-walled, which means the glass does not, or the index of refraction is not calculated, but it looks transparent and it's reflective like glass. It just does not bend light at all. So when you're doing architectural work, maybe you have a building with like 100 windows in it. You're not going to model each of those windows as a little individual block or have three-dimensional glass in it. You're going to do a plane. And you want it to look like glass, but you don't need it to calculate refraction. So that's why we use thin-walled for window panes. So under geometry, think of thin-walled as window. Now, if you do this on, say, a sphere, it will make the sphere look like it is a hollow, thin-walled ornament or glass ball, as opposed to being a solid glass ball. Without thin wall turned on, it's going to be a solid mass of glass that's going to calculate the index of refraction, bend light, and reflect light like solid glass. All right, so I did a couple of quick renders here. This is basically just a dome light, simple plane for the geometry, which was a sphere just to sit on. So I could just do a couple of quick renders. So the index of refraction for the sphere, I made it glass, was 1.0. I rendered it out, and you can see it doesn't look like anything's there. The reason I have it, sitting on a plane is because if I didn't have something to catch its shadow, you wouldn't believe I actually had an object there. It would be like me not having anything in that render. Now, the next render, just change the index of refraction to be water, 1.33. You can see that light bends as it passes through. I got a little shadow here, and it reflects a whole lot differently. Now, as I increase it from water to glass, 1.52 in this case, it bends light more. So it bends light as we're looking through it. It also reflects a lot more. When we get to a diamond, much denser. So light gets bent a whole lot more, and it becomes a lot more reflective. And all the other settings are the same, except for that index of refraction. So the higher the number, the denser the material, the more it's going to bend light, the more it's going to reflect light. Now, we talked about worrying about the specular part of our render settings. We start to get noise inside the reflective portions. Now we're also going to have to look at the transparent parts, that transmissive. So here we also are going to need to increase the transmission rays from 2 basically to 4, 6. I doubt you'll have to go to 8, but it is possible depending on your scene size, the lighting in your scene, what you have going on. Now, also down under the Arnold renderer, down a little further past the sampling part at the very top, there's a section called ray depth. So it's a global control for the max specular number of bounces in a scene and the max transmission numbers that you have. So the settings I have here are the default. So basically there's a total of 10. 10 being 1 diffuse, 1 specular, and 8 transmission. So for example, if we have a glass with liquid in front of a glass with liquid, we know we would need to have 12 rays, or the ability to go through 12 surfaces. So we would need to up our transmission number from 8 to 12. This number is also going to have to get increased. We're going to have to increase the total, and we're going to have to increase the transparency. So if we increase this to 12, that's going to make this 14, because 12 plus 1 plus 1 is going to be 14. Now, specular, you might need to increase this number too. So you might need to go to 2. So if you do that, just remember total and depth need to equal whatever you do to diffuse, specular, and transmission. Be careful with these numbers. They can really increase your render time. But transmission is probably the most important one, because that's what you're going to notice the most. All of a sudden, hey, I can't see through. Whereas this is the total number of rays that we see through an object. This is how clean the render is in those areas. So this is noise, and this is the ability to see through and reflect off of. Now, depending on your camera angle, and specular should be the same as specular weight. Specular weight. Can you do that a little more? Can you elaborate on that a little more, Allegra? So transmission should be the same as refraction ray. Specular should be the same as specular weight. Well, specular weight is at 1, which means it's full reflectivity. The weight doesn't have anything to do with the number of rays. So when I was talking about transmission, I think this is what you mean, Allegra. Transmission, remember, you've got transmission, the number of transmissive rays that are in the renderer by default, meaning we talked about our glass surface here. We've got a glass with 4 surfaces. Our camera needs to see through 4 surfaces. So where is it? This number of 8 is more than enough. We have glass in front of glass. That 8 is still fine, because you've got 4 for an empty glass, 4 for another empty glass where they overlap. So 8 is fine. But if we had water inside the glass, how many surfaces would our camera have to go through to see through the glass with liquid in it? So single glass, though, for now. Yeah. So Jasmine said 6, and she's correct. So got a surface here. So this has 2, the glass has 4. That's 6. So now, if we have a glass with liquid in front of another glass with liquid, how many surfaces would our camera have to see through? So 2 glasses with liquid. Well, if each one has 6, what's the overlap going to be? 12. There you go. So that is where you would need to change this number from 8 to 12. If one had liquid, then you would just calculate, one has 6, the other would have what? 4. So the total would be what? 10. So that you would make this 10 instead of 12, or 10 instead of 8. So Does that kind of answer your question, Allegra? Allegra, do you have any more questions? Did that answer your question? Kind of. Is refraction ray amount a setting outside of the render settings? Refraction ray amount. Good question. Let's go into Maya and take a look. Some renderers have the ability, like RenderMan had the ability for you to target each setting inside the material for the number of rays that it would accept. And then you had a global control as well. So by amount, you mean these surfaces it has to go through. Yep, no, I know what you mean. They call it ray depth. That's what this is. That's how many surfaces a ray has to go through. In our case, it's mostly camera rays because we're not doing any simulation or anything. All right, there we go. So let's just make a standard AI surface, which is pretty simple. Shift T. Well, I got to select the surface, I guess. So let's go here to make a sphere, Shift T, AI standard surface. There we go. So here under transmission. So if we turn transmission all the way up, there we go. We've activated it. Now, basically, we've got glass. But a lot of times you need to go down. So here's geometry. There's your thin walled. Here is advanced. This is where you turn on your caustics. There's your indirect specular, which is basically just adding a little more intensity to the specular reflection. But to answer your question, there is not a separate control for the amount or the ray depth amount for glass or reflection outside the render settings. So they're kind of global controls. So when we go in here, under here, right, we know we can set up for a decent diffuse render. Say, for example, we have that. Right now, specular, if you've got a lot of reflectivity, you've got a mirror, you've got reflection in front of a, glass in front of glass. No, not glass, mirror in front of mirror, where you have infinite reflections. This is where you may need to turn it up because as it reflects back and forth, you're liable to see noise. So think of all this as render quality. Down here under ray depth, this is the number of rays that go through a surface. So they always set transmission up to be higher because most of the time, if you've got a glass object, you've got at least 4 surfaces. If you put liquid in it, you've got at least 6. So 8 is a good starting number. Now down here, specular, if you notice that your reflections are kind of falling off a little bit, then you need to increase this. But I would be very careful. Increase it by 1 number, then maybe 2 at the most. But don't forget, these numbers in here have to add up to the total. So if we change this to 12, this has to be 14. Because 12 plus 1 specular, 1 diffuse is 14. Transparency really hasn't changed. except that maybe you change this to 12, because that is our transparency for transmission. So I know it kind of looks scary. It's really not that awful. Right now, depending on the angle of your camera, you can have a scene that, for example, this long shot here, this is before the days of denoise filters. In order to get this clean, it took about 1 hour and 6 minutes for me to render this out. Now, that's not too bad, but as soon as I moved the camera, got closer to the glass, and I had all of this overlap, then my scene almost doubled. So based on your angle, the camera angle, your scene render time could increase significantly. Just because it looks really good in a long shot where maybe you don't have a lot of overlap like I have here, right? But you get into a close-up shot and then you've got a lot of overlap. Now, I was kind of talking about this little bottle right here. I did mention this sort of when I was talking about some of the interesting glass shapes that you have in the interior. This is called a Klein bottle. So a Klein bottle fills from the bottom up. So that means the neck of the bottle goes through the body. So this ordinary glass shape up here, how many surfaces up here? Right at that spot. There's 4, right? But when you've got this surface going through the body by itself right here, this also has 4. But here, how many surfaces would our camera have to be able to see through? 8, yep. Because that neck goes through the body. So it's a very unique shape. In fact, believe it or not, there are total like user groups for people who are Klein bottle freaks. Yeah, I think there's a Facebook group for Klein bottle enthusiasts. I think you're right, yeah. So take a look at, let's go look at images. Klein bottle. So it's interesting. I love this shape because it was a mathematical possibility in the days of, let's say, early glass blowing. Because if anybody's ever seen glass being made, it is a really tough process. You have a blob of molten glass on the end of a really long metal tube, and you blow it, and then depending on how long the tube is, somebody has to shape it on the other end. So you blow it, you shape it, you blow it, you shape it to get the shape you want. It's really hard to take the neck of something and then shove it into the body of the bottle and have it come out the bottom and you smooth it out. Now, there are glass blowers, believe it or not, who specialize in making Klein bottles from scratch, blowing them traditionally. But this really wasn't possible until the days of injection molding, where we made a mold, we could pour molten glass into that mold, let it cool, break open the mold, and then we have our glass shape. Now, granted, you can do that with sand if you know what you're doing and 2 pieces and put it together. But in the early days of glass making, everything was pretty much blown, or it was shaped kind of traditionally. Really didn't use a lot of mold making. So there's all kinds. I mean, there's really interesting shapes. So you can buy these made with plastic now, and they're kind of a little on the expensive side, but if you ever, get a chance, take a look at one. It's pretty interesting. They make special bendy straws, so you can get up and go around if you actually wanted to drink out of it. Because basically you fill it from the bottom, and then of course you have to stick the straw in through the bottom and all the way around and then drink. So anyway, that's the reason that we're talking about Klein bottles, because of this unique shape. Now, coming back over here, this bottle would have, by itself, would have how many surfaces for our camera to look through? Nope, just this bottle by itself. 4, yeah. All right, so this vase over here, how many surfaces would that have? 4, yeah. And then where it overlaps, yep, it would be 8. Allegra asks, how would you wash a drinking Klein bottle? Not sure, Allegra. I don't have one, but I imagine you would have to use some kind of pressure wash system where you'd have to force the water in there, get it to agitate around, clean it, then put fresh water in there, and then dry it out, probably with compressed air. So Eel says, can you drink out of that? Yeah, theoretically you can drink out of it. It's going to be a little difficult, but yes, you could drink out of it. Like I've said, I've seen people in their Facebook group have like Klein bottle parties, and they give Klein bottles out with beverages in them, and then they give you bendy straws. So basically, you'd have to fill it and kind of like follow it around, and then fill it a little more and follow it around. Yeah. And then just hope it doesn't dump back on your lap. All right, so one more bottle over here. This one is kind of an hourglass shaped bottle. So this hourglass shaped bottle looks like there would be only 4 surfaces, but this cap up here kind of has a little bit of a mushroom lid going on. So right here, the normal like body of it, this would be 4, but up here, this would be 8. So you need to configure it for, I don't want to say worst case scenario, but for the most number of surfaces that your camera has to go through. So remember, when you are adjusting render settings, they are global, they are for your entire scene. So if you adjust this for the Klein bottle, you're automatically adjusted for this bottle here. And if your other bottles don't need it, it's not going to use them, so you don't have to worry about it. But you do want to make sure you don't add more than you need, because you don't want your computer calculating something that doesn't exist. So, I mean, if you have to use it because you've got glass somewhere that's visible to the camera that needs to be, needs 8 surfaces, you want to keep your settings as low as possible, just like render quality settings. You don't want to add any more in than you need. Yeah. So basically you look at your scene and go, okay, look at your long shot, look at your close up. Where is the most overlap I have? Well, in the interior, honestly, it's going to be the Klein bottle, because when we zoom in on the desk, the Klein bottle's sitting there. Other than that, there is basically no glass overlap in the long shot. The other glass you have are on the shelf above the TV, and there's one bottle over on the table next to the sofa. For the long shot, no, you would need to put it in there as 8. I'm just saying that it doesn't look like there's any overlap in the long shot, but technically there really is. And there's also this hourglass shaped bottle above the TV. All right, so while we're on this topic, before we actually get in and start demoing glass, let's take a look at this. So here is your exterior scene. Now, let's do a quick analysis of this. So wine bottle, how many surfaces? How many? 4. Yeah, good. All right, wine glass by itself, 4. How about the liquid, the wine itself? How many surfaces just for the liquid? 2. So wine and glass together equals 6, right? Now, what about this area right here? Yep, because they all overlap at the same time. All right, what did you said what? 14. Okay, why 14? But we don't have 8. Right, that's 8 together. Well, no, it's you. Right. Well, see, the glass is 4, the wine bottle's 4, there's 8. The liquid, you said, is how many? 2. So 4 and 4 and 2. The bottle is empty. 10. Okay, good. So yeah, our bottle is empty. So all your reference images for wine bottles should be empty. The only liquid we have is inside the glass. There you go. So 10. So down here, where are we? Right here, we need to change transmission to 10. So then we would crank this up to 12. So transparency depth is 10. That should be totally fine because we're not going past 10 in transmission. Now, you are absolutely correct. If our wine bottle had liquid in it, then we would be dealing with 12. But wine bottle is empty. All right, does that kind of make sense? All right. So what I'm going to do at this point, questions? Diamond, Adriana, Jasmine, good? What inside the desk? The mug, yes. The mug's got to have its own material. And there's also liquid inside of it. You can make it whatever you want. Honestly, I don't believe that liquid's seen from the camera angle. You have to go above it, but I would still put a material on it and give it whatever you think it should be. Coffee, yeah, I mean, that's pretty simple. Coffee's not really all that transparent. Tea's a little bit more transparent. Okay, Allegra's good. Damien, Daya, Eel, Griffin, Joshua, Tristan, everybody good? All right, so let's go and make some glass for the exterior. We're going to do that first, then we'll take a short break. We'll come back in. I'll show you how to do the interior. The interior is actually, if you know how to do the exterior, interior is pretty much the same thing. But I'm just going to kind of go through making that brushed metal thermos on the container and kind of show you my process for when I look for reference images. I have a nice reference image for the table. I want to use that, and I'm going to show you how I approach like figuring out the reflectivity and all of that. All right, so let's do this. Let's minimize that. We already have Maya running, which is good. Don't have to wait for that to launch. So what I'm going to do is set my project. Couldn't find good candle reference. So Allegra, you're talking about the exterior night, right? Oh, yeah. Right. Those we don't have lit even at night. So they are not, well, let me set my project. Let's open up the interior and then we'll deal with the exterior. It's probably going to be a little easier. Interior, there we go. Lighting, I'm going to use my day scene. Well, it doesn't really matter. Should I do day or night? All right, I'm just going to use day because it's a little easier to see. Day, here we go. Eel says, if you find a good reference for something, but maybe the color isn't what you want, does the color have to match? Well, you need to find color on your object that matches your reference, Eel. That way you know how that color with the material reacts to light. It's one thing to be able to say, I would like the way that candle material looks, but I want it to be in purple, but I don't have purple. It's really going to be hard because if you take like purple from a plum or purple from another object, it may not have the same properties. So yeah, you really do need to find it so you can really get a good sense of how, for example, a candle, purple candle, how does that color reflect light? How rough is it? What does it look like? What color do you want the candle to be based on your reference? Yeah, what color do you want your candle to be? That's basically what your reference should answer. All right, let's do this. All right, let's go to the long shot. Actually, let's go to perspective first. Zoom in. So there's a candle here, and there's a candle up here, and there's another one up here. So those two were quite visible to the camera. What's that? So candle, candle. They can both be the same candle, same type of material. The one on the desk, I'm not entirely sure that's visible. Let's see, living room. Oh yeah, it is. It's a little bit visible. So yeah, you do have to worry about it. So Allegra says couldn't find good candle reference. So let's images. So let's define the kind of candle we're looking at. So there are candles that usually you put on a table, and then there are bigger candles that you use for mood and maybe for lighting. The one thing that comes to mind, I know it's not the right name of the candle, but those big Yankee candles, like the Yankee Candle Company, they're big, gigantic candles. That kind of candle is similar to what we have in the scene. So let's try and define it by candle types. So pillar candles, there's round candles, there's tea candles, these little tea candles that are really small. You put in little, containers. Here we go. There's a nice little image. Votive candles. Those are what I kind of was thinking of. There's jar candles. So you have to kind of decide which one you're after. Probably, I don't know if votive would be the right word for the candles in our interior. They might be more pillar candles. So let's see if we can find reference for pillar candles. Now, again, you want to try to, well, you have to avoid these magical matrix backgrounds. Something like this, that probably would work. I mean, you got a background in there. You got visible light sources. Not really great. This one's pretty good. Our flame is not on, but you get a good idea of what the candle looks like. This one. Oh, good. Yeah. And don't forget under tools, you want to go large size too. Yep. So that's a good point, Allegra. So when you're having trouble finding reference, try to define your search to what exactly am I looking for? So candles is pretty generic, but let's define it by what the actual type of candle is. Kind of the same thing for glass. Glass could be a bottle. It could be a mirror. It could be window pane. We're just trying to, kind of refine that search down to what we need. All right, so we got that. Let's go into the exterior. Let me set my project for that. Let's open up. We'll do the day scene. And I'm going to save as, just in case Maya does its usual Maya-ness to me. Let's go 2021-07. So I'm going to do a quick render just to make sure. Let me make sure that my render settings are not astronomical. Okay, how about down here, ray depths? Yep, that's default. That's good for now. And let's just make sure everything renders. Okay, beautiful. So when you're making glass, first thing you want to do, find reference. So we need to find reference for a wine glass with wine in it, and then empty wine bottle. What about wine glass outside? And let's go tools, large. There we go. All right, so something like this, well, that's not a bad picture. It's really hard to see through. That really doesn't, our goal is to be able to see through that line a little bit. Something like that would work. But now we have to decide, okay, this is kind of like our candle discussion. What kind of wine do we want in our glass? Do we want red wine? Do we want white wine? Or do we want like a pink wine, like a rosé or a Zinfandel? And a lot of this is also going to be based on what are the requirements. So if you go into project 6 down in lecture 7 milestone, okay, for the exterior, okay, the wine glass needs to be clear, the wine bottle needs to be colored, and the wine in the glass will need to have a colored liquid based on your reference. Now, also, we've got a wine label right there, wrapped around the outside of the wine bottle. Okay, that label needs to be hidden. So we're going to place it on a display layer and turn the visibility off. We will use that wine label for project 7 if you decide you want to do this environment in project 7. Right, does that make sense? Now, the only reason we're kind of hiding it is because we don't, I mean, wine labels are, let's face it, they're graphically oriented, and just having a color on a wine bottle kind of detracts from the wine bottle itself. We're more interested in, do you get the glass than if you can get the paper right. So, channel box, let's create a display layer. There we go. Let's turn off that. Now, we're all set. So we placed the wine label on a display layer, turned off visibility. Now we're all set to go. So now we're back to what kind of wine do we want in our glass? Yep, forget these reflective copper, metal, specialty goblets. No color in the glass. It's going to be a standard. Which one? This one? That's not bad. It looks like it's floating. Doesn't it? Kind of looks CG to me. Really hard to tell. Yeah, you can't really see through the wine. Plus, I don't like the fact that it looks like it's floating above the actual object that it's sitting on. So, yeah. These are pretty good. This one's not bad. That one's too dark, but that one's not bad. You got, at least you can see nice shadow in there too. Say that again. This one? All right, so that would be rosé. Okay. So yes, that is possible. We could use that. So let's see if we can save that image. Let's go to desktop. Yep, there we go. We got it. All right, so that'll work. So there's our reference. Okay. So we've got nice clear glass here. And you can see that that glass is not really that blurry. Okay, now you might notice that the glass to the left is a little on the blurry side. That's because the photographer is using what's called depth of field, meaning they're focused in on this glass right here. Those reflections are really super clear. But the ones to the left, they're slightly out of focus. All right, we're going with, this is how clear and clean our glass is here. So getting reference and making sure that you're using the correct image in your reference is important also. All right, so we're going to use this center as kind of our guide. All right, so to make glass, let's select our object first. First thing you want to do, which we already found reference, is let's assign a new material. Shift T, AI standard surface, call it wine glass. All right, now we have found our reference. I threw the standard AI material on there. Now we need to start shaping it into glass. So first thing we want to do is we're going to turn off the base weight. Turning off the base weight, now we are left with just total reflectivity so far. Now, notice we have a good shadow here. Now, to make this glass, well, we're going to leave the specular weight at 1. We're going to leave the specular color. I'm going to lower my roughness to 0 right now, just temporarily so I don't forget and have blurry glass, basically. All right, index of refraction is 1.5. That's good. Now, let's turn the transmission weight all the way up. So notice when I turn my transmission weight all the way up, what happened? See, I had a nice shadow. I turned transparency up. I lost my shadow. So the only shadow you see is that big piece of clay sitting in the glass. That's my geometry for the wine. Now, this is why we need to use those two utilities I talked briefly about in the slides. Here we go. Transmission weight. Because when we turn the transmission weight all the way up to 1, we get glass, but we lose the shadow. In order to get the shadow back, we need to use what is called a gamma correct node. And that gamma correct gets plugged into the transmission weight. So I click on it. And this is what's called a Maya utility. So under Maya, I go to utilities, and these utilities are all alphabetical. So I want to go down to gamma correct. So I scroll down, there's my gamma correct right here. Now it's going to give me a connection editor. It looks complicated, but this is the same connection every time you make glass. So we take the out value of our gamma correct, which is right here, out value X, And we want to plug that into transmission. So we got a shadow. But it also screwed our glass up. All right, so now we close this. What we want to do here is we're going to, since we're using the out value of x, the gamma has controls for x, y, and z. So we're going to make our x 4 and our y 0 and our z 0 also. We're not done yet, almost. We got a shadow back. This is all set up so that the very next step will give us a shadow. The very next step is we take our value, we click on that value, and we plug in another utility. This is called a sampler info node. It basically samples the surface based on where the camera is looking at. So we go to utilities, and I go all the way down to S, sampler info. And all I have to do is take the very bottom. This is my sampler info here. It's called facing ratio. That's the facing ratio of the normal to the camera. We click on it. We go up to value. Notice value is grayed out, but we can expand it. And we want to take the X because we've been using X for everything. So we go facing ratio to X value. And now we have a nice transparent shadow. We're almost done. The glass is okay, but the sides are a little on the kind of washed out look. It's kind of dark. It feels almost dirty. So let's go back to the actual object now. So for this, we go down to advanced. We turn on caustics, which will add a little bit of sparkle to the glass. And then we increase our indirect specular to 1.1 we go from 1 to 1.1. So now it makes the glass come alive. So here's all that nice little sparkle we got down here. So our glass now has a shadow that looks believable.
Can you do that last part one more time?
Can I do what?
That last part, what did you change to 1 point something?
That was the indirect specular down here under advanced.
Okay. Thank you.
So I turned on caustics and then increased the default indirect speculars 1. We just bump it up a little bit to make a little more sparkle. So that is basically the process. Now, like I said, making glass is really simple, but you lose the shadow if the shadow is crucial. Like for glass window panes, don't care. Don't have to worry about that. But for a glass object outside in a lot of light, we need to worry about this. All right. Now, having done that for you, here is the slide that I'm going to take a screenshot of. So this is basically the recipe for making glass. So let me do a quick screen grab for you guys. And if you're watching this in the archive, just pause the screen. All right, there it is. And I will drop that into the chat. And you guys should be able to have that. So find reference, assign your new AI, turn off the base weight, make sure the specular weight and the specular color are the default. Adjust the specular roughness, transmission roughness from the reference. Right now, my reference, that glass is pretty clean. So consequently, I have perfectly clear, pure glass. Honestly, I'm going to bump it up a little bit, maybe to 0.01, because nothing is perfectly clear. I'm going to go down under extra roughness, 0.01, give it the same. It's just going to add a little bit of imperfection into the glass. And it's really not going to be that noticeable. Just a little bit of imperfection in there.
What did you change to do that?
I increased the roughness just a little bit to 0.01 to add a little imperfection in the glass. Yeah, nothing is perfect. Now, the one tough thing is if you leave the default of 0.2 in there, that's a lot of roughness. That makes for hazy glass. And that's, unless your reference is that, don't do it. But in order to have actual realistic looking glass, the roughness is part specular and part transmission. And I like to give those two the same number. Just a little touch of roughness. All right, so there's our recipe. So the roughness, index of refraction, glass is already set to 1.5, right? Transmission weight. This is where we turned it up. We got glass, but lost the shadow. So then we need to create a gamma correct utility in the transmission weight. Out value X, we input that right to transmission, close it, adjust the gamma correction attributes, which we make the gamma, we keep the X at 4, or we move the X to 4, and we turn the Y and the Z to 0. Then in the value, this is where we plug our sampler info node in, so that it measures which angle or I should say, what the camera's looking at is measured off the surface. So that is under the value. We select facing ratio in the gamma or in the sampler info. We plug that into the X value of our gamma correct, and that then adds in our shadow. We go down transmission color. Based on your reference, clear is white glass, or white is clear glass. And then we turn on caustics and increase the indirect specular to 1.1. So for now, specular transmission, we want to make sure that we adjust those settings if we need to under the ray depths. Right now, it's set to be 8. But I know here, I know this is going to need to be 10. Just because I've got 4 for the bottle, 4 for the glass, 2 for the liquid. Where they overlap, that's going to be 8. I'm sorry, that's going to be 10. So here, this is where I'm going to put 10. Total up here, going to make that 12 because 10 and 1 is 12. Down here, keep that at 10 because that's the same number as my transmission. I should be okay. And of course, save your scene. So now we go on and we do the same thing for the wine inside the glass. The wine inside the glass, we need to figure out what is the index of refraction for. In this case, we've got rosé wine. But let's just find the index of refraction for wine in general. So you can go to a bunch of websites. Ooh, Vista Winery. Let's go see what they have. I always like to go to wine websites because they're the people that make wine and they measure it for clarity and purity. Where are we? Barrels for sale? No, don't want a barrel. Just tell me what the refraction is. Right here? Oh, there we go. Okay. All right, so let's go liquids, liquids, liquids. Liquids. Liquid. How about wine? Well, we got whiskey, but yeah, that's kind of not impressive. It's a shame. All right, that's taking way too long. What's going on here? Wow. All right, there we go. Whoa, that's more than I want. Oh, here we go. Alcohol content. Looks like it's 1.34. 12 red wines. Eh, 1.345. All right, let's go 1.345. Sounds like a joke number. So let's go into the wine glass group, select the wine by itself. Let's go to perspective. There we go. All right, so assign a new AI standard surface. First thing I want to do, my little checklist of love here is we found reference. We assigned our new AI standard. Let's turn off the base weight. We've already got the index of refraction here, which is good. So base weight off. Let's render. There we go. Now we got a big black lump of tar sitting in our glass. Yummy, yummy. All right, so specular weight, specular color stays the same. I'm going to turn my roughness down to 0 for now. Index of refraction, we're going to do 1.345. Transmission, we can turn it up. There we go. Right now, we've got clear wine. But notice we lost our shadow inside the glass. Now, before we go ahead and I add in the sampler info and all that other stuff, let's give it the color we need. So what I'm going to do is the color for glass goes in transmission. So I'm going to double click and do exactly what I did when we sampled the color for metal. I'm going to open up my advanced color picker, load my reference in the color wheel section, to image, load, got it on my desktop. There it is. And let's sample the color here. Now, I want to avoid super dark areas. I also want to avoid super white areas. Let's try and find a nice area that looks like it's representative of that wine. And that's a little dark. Oh, let's try again. Other side? Okay, actually that's not looking too bad compared. So let's see, okay. Let me stop that. Let's remove that. Because I really don't want to wait for the denoiser. I mean, it looks great, but there we go. Okay. Where's my reference? Right here. All right, now, notice that since I made it color, I have visibility in the shadow. I'm still going to go ahead and give it the gamma correct and the sampler info, just to make sure that I get the edges to be a little bit darker, like they should be in an actual reflection. Should be darker color on the edges and lighter in the center where the light's mostly going through. So I'm going to select my geometry. Under transmission weight, this is exactly where I'm going to put in my gamma correct. So again, under Maya, utilities, it's alphabetical. So if you get lost, just use the checklist. So gamma correct out value, X to transmission. Click close. Kind of made it black again, that's okay. Now, under the gamma section here, X is going to be 4, Y is going to be 0, Z is going to be 0. And last, we add our sampler info into the value section of the gamma. So click on that, brings up the create render node. We go to utilities under Maya. It's alphabetical. We go down to sampler info, click on it, 2 connections, facing ratio, which is facing the camera, facing the geometry, picks up the normal information. Under value, everything we've been doing has been plugged into the X component. So we plug X in. So now we got a little bit darker edges in our color, and it looks a little more natural. Two other things to do. So we got our color. Let's turn on caustics and then increase our specular, our indirect specular to 1.1. So select the geometry. Let's go down to advanced, turn caustics on, and indirect specular to 1.1. There we go. Adds just a little more sparkle into the wine in our glass. And not too bad of a match for our reference. Now, just like the wine itself, I'm going to give it a tiny bit of roughness, just so it's not perfectly pure, clear wine. Just a little bit. So that's going to be under specular roughness. I'm going to add 0.01. And also, under the transmission. Extra roughness, 0.01. Yeah. So now it looks a little more like our reference. All right, so one last thing we need to do. Wine bottle. First thing, find reference. Now, even though some of the reference for rosé wine bottles are clear, we still need color because we want to make sure you know how to make colored glass. We made color liquid, but let's make colored glass. So you have a couple of choices. The most common colors in wine bottles are like green. I've seen blue, not necessarily with rosé, but I've seen blue, and I've also seen kind of an amber color. You've seen what? Black? Okay. Well, for our purposes, that's not going to work because we need to be able to see through that bottle a little bit. All right, so let's find empty wine bottle. Empty wine bottle outside. There we go. Avoid the bottles that they make into lamps. And also tools, size, large. So actually these work pretty well, the first couple of choices. This is inside. Not bad. Actually, it looks like the same set of bottles. So we got this dark amber, we kind of got an olive green, kind of maybe consider it a light amber, and then we have green. So which one should we do? This one? Dark one? Oh, the light one. Like one of these. Okay. Front or back? Front. Okay. All right. So let's see if we can grab this. Actually, which one's better? I like this one better. It's got better light. Save image. Desktop. Yep, that'll work. And here we are. All right, so we're basically going to do the same thing we did for the wine. Obviously, well, minus the fact that changing the index of refraction because it's glass, so it's going to have the same index of refraction. All right, so our wine bottle's next. Assign a new AI standard surface. Somebody want to walk me through? What are we doing next? All right, let's turn off base color. Actually, let me rename it first. Wine bottle. Okay, wine bottle. Turn off base color. There we go. Base color off. What's next? Okay, so we know that the specular is good, right? The weight's good. The color's good. The only thing you might want to do is turn the roughness down temporarily so that we don't get an overly rough looking object. And then transmission weight. There we go. So we had a really nice shadow. Now we don't. So before we go in, we add in, so Allegra said you chose the same reference. Is that okay? Yes, you can use the same reference. So let's do color, and then we'll go in and make the shadows. So color. I'm going to do the same thing I did with my wine. I'm going to double click on the color swatch, open up the advanced color picker, color wheel, load. Let's load our reference in, and let's sample. So again, I want to avoid super dark areas. I want to avoid super white areas. Now, once I sample it, I can always come down here and make it darker or lighter. You want to avoid, when you're sampling colors, you want to avoid having too much value in your color, because basically you're just shutting down the transparency. You're basically making it black. So still, let's see, how does that feel? Does that look about right? Nah, it feels a little on the, looks like there's too much orange in it. How about that one? Looks like it needs a little more green in it. So what happens if I pull it towards green a little? So this is where sampling is good, but then you can adjust the hue on your own. Yeah, that feels a little closer. Just pulling it out of that dead yellow over more towards the green. Actually, that's not too bad at all. You can, but here's the problem. A lot of rosé wines have clear bottles. And for this exercise, the wine bottle needs to be colored. So, however, for Project 7, if you want to do this and you find a clear rosé wine bottle, use it for Project 7. But for this, we're just trying to make sure that you understand how to make color and how to make clear. Good question. All right, now, we kind of have a uniform looking shadow there. Let's get some dark edges on that. And this is where we plug in our gamma correct and sampler info into transmission weight. So somebody walk me through that part. All right, so transmission weight, right? We click on the little checker button. We want to go under utilities. Then we go to gamma correct. All right, so here, connection editor. Yeah, we want to go out value. We want to go out value of X. And then we plug that into Y. Yeah, we go into transmission. Right there. Now we close it. Now what? Okay, so Y and Z are 0, X is 4. Almost done. the value, we click on that. What are we mapping in? Utilities. Sampler info. Right there. Now what? Facing ratio. We're going to value X because that's where we've gotten everything. So now we got a nice little dark shadow on the edge of our wine bottle that we didn't have before we did this. Good job. So just like anything else, let's go take a look at our reference. So reflections look sort of clear. They do look a little, just slightly blurrier than the wine. So for something like this, I think I might give it a roughness of like 0.02. I could maybe bump it a little higher, but let's just try 0.2. And then we do the same thing down in transmission under extra roughness. What's that? Oh, yes. Good catch. So I added the roughness. Yes, we would. Because the glass, even though it's darker, should still have sparkle to it. So we added the roughness. We already got the color. So now we go under advanced. We turn on caustics. And then indirect specular 1.1. That just kind of pushes it to look a lot more like glass. And looking at the reflections on my bottle here, I can say, you know what, they look kind of little, you know, they kind of look like that. So I think we got the level of roughness sort of about right without being too excessive. All right, so does this process make sense? All right, good. Anybody have any questions out there in Zoom before we take a short break? So Allegra, Damien, Daya, Eel, Griffin, Jose, Josh, Tristan. Pretty good. Say again? No, TV screen is still, it's basically just going to be reflective, like, you know how you put your Mac, turn the brightness all the way down? It's going to look sort of like that. Unless it's at night. At night, it's still going to be a mesh light. Yes. So you're doing the nighttime for Zen, so you're doing the interior day, right? Okay. So yeah, this would look pretty much the same, just you would have candles illuminating your scene. What's that? Oh, yeah, yeah. Also, did you set indirect specular to 1.1 for the liquid? Yes. I did. So we go back in here. It's got the same settings as glass. So caustics are on, indirect specular. because the liquid's going to have caustics, the glass is going to have caustics, and the bottle's going to have caustics. So pretty much just follow the checklist here and you should be good to go. When we come back from break, we're going to do the windows for the interior. Because the geometry is turned off for the windows, we're going to turn the geometry on. We're going to make thin-walled glass for that. We're interested in getting reflectivity back in our scene now. So now we're going to see some reflections in the windows of our interior, even in the day, but mostly it's really going to be visible at night. All right, so let's take a short break. Let's take 20 minutes here.
In the chat.
I'm sorry, what did you say?
I have a question in the chat.
Is it new? Because I just answered your question about indirect specular.
Oh, sorry.
Yeah, I just basically went on a whole tirade about how indirect specular for the liquid has caustics, has indirect specular turned on just like it does for the glass, because you want that same level of sparkle to be for the liquid that's transparent as glass.
Okay.
Make sense?
Yeah.
Okay, cool. All right, so let's go back. And let's see. Let's come back at 9:35. That'll give me a chance to render out the first part of lecture. All right, so take a break. I'll see you guys back here in 20 minutes.